second speaker, Mrs. Mohini Kulkarni. Mrs. Mohini Kulkarni did her MSc and MPhil in statistics from University of Pune. Now she is teaching statistics in commerce and management courses since last 9 years. Currently, she completed coursework for her PhD in statistics from IIT Mumbai. Then her co-author, Arpita Deodikar, she did her MSc and MPhil in mathematics from University of Pune. And she is teaching mathematics in MIT. What is MIT? I see. Because so many MITs are there. MIT Engineering College in Pune since last 5 years. So they will be presenting their paper on discussion of solar and lunar eclipses according to Karanakutuhala. Of course, some in the announcement of programs and the speakers and the topics, some confusion arose in our mind because these two ladies are to present on lunar and solar eclipses as discussed in Karanakutuhala. In our next session, Dr. Padmaja Vedugopal is also supposed to make a presentation on the two eclipses from Karanakutuhala. So I advised our lady to discuss with these two ladies and to if they can have a sort of understanding. And I think one of them will be presenting lunar eclipse and the other solar eclipse. So I don't know which of them will be presenting solar eclipse. Yeah, solar eclipse is a more complicated thing which involves moon's parallax and things like that. So I request the two ladies to make the presentation, totally amounting to 20 minutes.
Thank you, sir. Respected Chairperson, Dr. Balchandra Rao, all the dignitaries sitting here, and ladies and gentlemen, a very good afternoon to all of you. It's my privilege to present this paper in the presence of Dr. Balchandra Rao, who has immensely contributed to the Indian ancient astronomy through his books, and these books have also been the basis of my present study. As said by Varahamihira in Brihat Samvat 513, Ivaha Puraga Karanamuktamidam Divyadruk Virakaryam Rahu Karararanam Asmin Yukta Sastra Sadvaha. The ancient seers, endowed with divine insight, has explained the causes of eclipses. Hence, the scientific fact is that the demon Rahu is not at all the cause of eclipses. Now, I request my co-author to read the next part.
Good afternoon, all of you. Bhaskara's work in algebra, arithmetic and geometry as presented in Karanakutuhala and Siddhartha Shiromani catapulted him to fame and mortality. In 1183 AD, when he was 69 years old, he composed another astronomical text called Karanakutuhala. His another important work involving astronomical calculations is Siddhartha Shiromani, which consists of the 4 parts, namely Lilavati, Bijaganitam, Grahaganitam and Goladhyaya. Grahaganitam and Goladhyaya are completely devoted to computations of planetary motions, eclipses, etc. and the rationals of spherical astronomy. Among the all Siddhantic texts, Bhaskara's Siddhanta Shiromani merits as the best and exhaustive text for the understanding Indian astronomy. In the present paper, we have tried to explain the procedures and the algorithms presented in Karanakutuhala and Siddhartha Shiromani with references to solar eclipses. For the particular chosen date of solar eclipse, the computations for different parameters are of solar eclipse explained.
We have made a small attempt to understand the calculations made by Karanakutuhala, which are explained in Karanakutuhala as well as in Siddhanta Shiromani and Surya Siddhanta. So, this is the diagram for solar eclipse. S represents sun, moon represents, M represents moon and earth. on the new moon day, that is Darsanta, it is called as Darsanta, the sun and the moon are on the same side of the earth and in conjunction. The rays of the sun S, which fall on the surface of the moon N, facing the sun, are prevented from reaching the earth. A shadow cone is caused under the following conditions. The sun and the moon must be in conjunction, that is, it must be a new moon day. The new moon must be close to one of the nodes, that is Rahu, which is ascending node of the moon, and Ketu, which is descending node of the moon. On the account of the inclination of the moon's orbit with the ecliptic at an angle of about 5 degrees, there will not be solar eclipse on every new moon day, that we know already. Consider the following diagram showing shadow cone during the eclipse. Now this is the exact the angular cone at the time of eclipse. From the above figure, the shadow cone of the moon formed by the tangents of the surfaces of the sun and the moon has its vertex at V. This shadow cone is called umbra. The penumbra region is obtained by drawing the internal tangents to the surfaces of the sun and the moon. For the region on the earth represented by at K, figure 1 of the umbra, the sun is completely obscured by the moon. Hence, there is a total solar eclipse for that portion of the earth's surface. The moon's angular semi-diameters. Now, the different cones are representing the different parameters. The moon's angular semi-diameter is S dash, that is angle MEP. The sun's angular semi-diameter, angle AES. Angle AC is sun's horizontal parallax. Angle OBE is equal to angle CBE, that is approximately horizontal parallax of the moon. D is angle AES plus angle MEB plus angle OBE minus angle EAC, which gives the angular distance between the sun and the moon with respect to the center E of the earth at the beginning or at the end of the partial solar eclipses. Using the values of sun's diameter, sun's semi-diameter, that is angular diameter, angle AES is 16 minutes and moon's semi-diameter, angle MEB 15 minutes. Sun's horizontal parallax, angle EAC is 18 seconds and moon's horizontal parallax is angle OBE 57 minutes. Now I'm giving you the definition of parallax. It is a displacement or difference in the apparent position of an object viewed along two different lines of sight and is measured by the angle of inclination between those two lines. Now we are here starting the actual calculations for solar eclipses. The parameters required for computation of the solar, not lunar, this is mistake. This solar eclipse are two longitudes of the sun, the moon and the moon's node, that is Rahu, the true daily motions of these three bodies, the angular diameters of the moon's shadow. We consider an example. Now I have considered a particular example of solar eclipse on 24th October 1995 at Bangalore, and which was total solar eclipse. And for that, the following are the parameters or the facts, the longitudes and the exact positions. So the positions are given like this. The true longitude of the sun, 186 degrees, 18 minutes, 19 seconds. It is named as Nirayana. The names are given in Sanskrit in Karanakutuhala. So somewhat I could understand, I am writing the names which are in Sanskrit in English also. True longitude of the moon is 183 degrees 46 minutes 5 seconds. True longitude of Rahu 182 degrees 43 seconds. Sun's true daily motion 59 minutes 46 seconds. Moon's true daily motion 14 degrees 1 minutes 37 seconds, that is 841 minutes 37 seconds. Latitude of Bangalore, since we are considering a particular point on the earth which is Bangalore, that the latitude of Bangalore is at 12 degrees 858 minutes north, and longitude of Bangalore is 77 degrees 35 minutes Daily motions are given in revolutions per day. Now the first calculation is I've done for instant of conjunction. The instant of conjunction on a new moon day is necessary for computing solar eclipses. And instant of conjunction is given as sun's longitude minus moon's longitude. That is the difference between the longitudes of the sun and the moon, divided by difference between daily motions of the sun and moon. So that means at the time of conjunction they will be in collinear, in the same line. As we are counting, so the time counting is in the morning, it's 5:30 a.m., 5.5 hours. Therefore, instant of conjunction, so I put the values, and the value for the instant of conjunction we got in as 5 hours 30 minutes, plus putting all the values we have already mentioned. The calculation we have got as 10 hours, sorry, 9 hours 7, it is 10 hours 10 minutes. So that is, it is vinadis, it is given in nadis and vinadis, 25 nadis, 25 vinadis after midnight. That is 11 nadis, 40 vinadis after 5:30 a.m. Nadi and vinadi is another ancient unit of measuring time denoted by N and V, where one day is 60 nadis, that is Gatika, and one nadi is 60 vinadis. Now the next parameter to be calculated is longitudes at the instant of conjunction. Motion of the sun in 11, so that at time span we are calculating motions of the sun and the moon. Motion of the sun in that time span, that is 11 nadi and 40 vinadi, is 11 nadi 40 vinadi into 59 minutes 46 seconds divided by 16 nadis, which comes out to be 11 minutes 37 seconds. Therefore, the sun will move 11 minutes 37 seconds in the time span of 11 nadis and 40 vinadis. That is in 280 minutes. That is in 4 hours 40 minutes after 5:30 am. Therefore, longitude of the sun, we have to add the time degrees. So it is 186 degrees 80 minutes 9 seconds plus 11 minutes 37 seconds, which comes out to be 186 degrees 29 minutes 46 seconds. Similarly, I have calculated motion of moon's motion following as the same way as we did for the sun, and it comes out to be 2 degrees 43 minutes 41 seconds. Therefore, longitude of the moon is 186 degrees 29 minutes 46 seconds, which is exactly same as the longitude of the sun. Therefore, at the time of the conjunction, the true positions of the sun and the moon are longitude of the sun and moon. So they are same, 186 degrees 29 minutes 46 seconds. Now, node's daily motion is minus 3 minutes 11 seconds. So node's motion in that time span, that is 11 nadis 40 vinadis, is minus 0.37 seconds. Longitude of the node is, so we calculated longitude of the node by subtracting the node's motion, which comes out to be 182 degrees 42 minutes 23 seconds. Now the next parameter is to find the true diameters of the sun and the moon, which are called as bimbam. So this is the next parameter. After the longitudes, we are calculating true diameters of the sun and moon. In Indian astronomical texts, the usual procedures for obtaining the true diameter of the sun and the moon is, true diameter is given as mean diameter into true diameter is given as mean diameter into true daily motion divided by mean daily motion. Now, according to Siddhanta, it is assumed that the sun and the moon move at a common linear velocity. Now, the circumference, so this has shown the calculation for true diameter. First I have shown the calculation for mean daily motion. Which is with respect to the circumference is given by circumference of the circumference of the moon's orbit, it is 3,24,000 yojanas, it is given in yojanas. The sidereal period of the moon is given, therefore mean linear daily motion we calculated as 11,858.71693 yojanas. Similarly, the circumference of the orbit of the side is given, for the sun also we calculated, and mean linear daily motion of sun is calculated. Therefore, using the true diameter formula, the sun's diameter I calculated as 32 minutes 46 seconds, which is angular diameter again. Similarly, using the same formula, I calculated moon's diameter, which comes out to be 34 minutes 4 seconds. Now, the next measure, it's an interesting measure, which is given in Karanakutuhala, measure of obscuration, which is called as the intensity or the measure of eclipse. And it is called as Channam or Grasa or Grasamana. Grasamana or Grasa is given as, that 2 is in the denominator, some mistake in the, so it is actually Grasa is given by Chadya Bimbam plus Chadika Bimbam divided by 2 minus Spashta Sara. That is 1 upon 2 d1 plus d2 minus moon's latitude. Spashta Sara is true latitude of moon, where d1 and d2 are the semi-diameters of the shadow, that is Chadika Bimbam, shadow is Chadika Bimbam, and the moon is Chadya Bimbam. And Khagrasa is calculated as Grasamana minus Chadya Bimbam. If there is a Khagrasa is positive, that is Grasamana is greater than Chadya Bimbam, there will be total eclipse. Similarly, we can find mean linear daily motions of the sun. Okay, so that is repetition again. So this, don't consider these two lines. Next is calculation of half duration. Now half duration is called as sthiti. So after calculation of Grasa or Grasamana, calculation of sthiti or half duration of the eclipse. As explained by Bhaskara, sthiti is given as, it is in under square root, it is 2 into Sara, that is moon's latitude, Shara, okay, sorry. 2 into Shara plus Grasa into Grasa divided by moon's true daily motion. There is a difference between moon's true daily motion and sun's true daily motion multiplied by 180 Gatikas. Therefore, beginning and solar eclipse we can calculate using Sparshakala and Mokshakala. Sparshakala and Sparshakala and Mokshakala. Sparshakala is Darshanta, that is the time of conjunction, minus Sthiti, the time of conjunction minus half duration, and Mokshakala is Darshanta plus Sthiti, that is time of conjunction plus half duration. So with the given example, I have mentioned these values here, Sparshakala and Mokshakala, which comes out to be 8 hours 3 minutes 12 seconds for Sparshakala, that is Sparshakala, beginning of the solar eclipse, and Mokshakala, 9 hours 54 minutes 24 seconds. Thus the different parameters. So I have tried to understand these calculations. I have not much given the calculation attempt for considering parallax. I am not considered. So they have given there are big calculations for considering parallax. So we have to do the iterations for that parallax, and we get the corrected values more and more. So I am not given much. So I just mention these things. The different parameters. So these are the different parameters for the solar eclipse that I tried to understand. And the summary of the solar eclipse is beginning of the solar eclipse 8 hours 0 minutes 35 seconds, middle of the okay, I'm concluding. Middle of the solar eclipse is given 8 hours 58 minutes 36 seconds, and end of the eclipse 9 hours 52 minutes 25 seconds. So calculation of these parameters are also explained in other ancient astronomical texts by other ancient astronomers such as Ganesha Daivanya, Grahalagavam, Brahmagupta's Khanda Khadyaka, Surya Siddhanta, but the methods given by Bhaskara too were much easier and user-friendly. We can find the answers of different parameters found by Bhaskara's way, and the actual values given by the modern astronomical theories are quite similar. This is an uncomparable excellence of the ancient astronomy. On the similar lines, the scope of the paper is, on the similar lines we can find the different parameters of the lunar eclipse and can compare the results of a particular lunar eclipse as an example. I mentioned the references. I've referred books by our today's chairperson, Dr. Balchandra Rao. Thank you.
Why did you choose Bangalore's latitude? You could have chosen Bombay's latitude.
Yeah. Actually, it was somewhat easier to work with the latitudes and all that.
You
So,
need the delta minus 5.
yeah,
Natamsha.
yeah,
Why
Natasha.
instead of Bangalore latitude, you Bombay latitude?
Okay. Yeah, I not tried. I tried with this particular example, and I just tried to.
More interesting.
Okay.
If you give the latitude of Allahabad or Kolkata,
Yeah.
because totality might pass through.
Yeah, yeah, yeah,
Here it was not.
yeah.
If there are no questions.